So in this session we're going to be talking about choice theories of addiction, with a particular focus on the role that rationality plays. And I want to say from the outset that it's quite important when we talk about choice theories of addiction that that's not meant to intend that we think addiction is a choice, that people are simply choosing to engage in addictive behaviour. When we talk about choice theories, what we're really focusing on are theories which try to understand the way in which choices are ordinarily made and the problems that can arise in terms of how choices are made in the context of addictive behaviour, and therefore seeing, similarly to the idea that impulse and self-control theories construe and think about addictive behaviours as being a problem with the process of impulse control or self-control. In the same way, choice theories are a way of understanding addiction by understanding the way in which choices are made ordinarily and how that process of decision making can become undermined in the context of having developed addictions. So the particular focus in this session is going to be around issues related to rationality. So the first thing that we're going to do is go through the answers to the reasoning test that I've made available to you, and hopefully you've already been through all of that. And then we're going to have a bit of a discussion about the nature of human rationality and what we mean when we say rational thinking, rational behaviour, rational decision making, and then look at that in the context of intelligence and addiction, and finally finish on a particularly influential theory in the addictions field known as the theory of rational addiction. So in this first section, we're going to look through the answers to the reasoning task. Now, it's really important that you've completed the reasoning task, okay? This whole session will be a lot more fun when we go through the answers if you actually had a go at some of those questions yourself, or indeed all of them. So if you haven't done that already, stop, turn this off, go back and do the questions. Only 10 of them, take you 5-10 minutes or so, and then come back and watch the rest of this recording. Have you gone? Are you still there? No? Okay. Right, I think they've all gone. The ones that haven't done it have gone. So hopefully those of you that are left are the ones that have done it, and we can crack on now and take a look at the answers. So the first 3 questions in the test are syllogisms. And syllogisms are essentially a sort of a form of logic whereby you're presented with 2 statements, the premises, and then a conclusion. And the question that you're being asked when you're asked whether or not a syllogism is valid is, do the 2 premises guarantee the truthfulness of the conclusion? So if the first 2 statements are true, then would it logically follow that the conclusion would have to be true? And importantly, that's nothing to do with whether or not in the real world the actual conclusion itself is true. So whether or not you happen to know that the conclusion is true is irrelevant when you're looking at a syllogism. It's whether or not the first 2 statements guarantee the validity or the truthfulness of the concluding statement. And across all 3 of these syllogisms, not one of them is valid. So even if the premises were true, and I'll go through the answers in just a moment, or the particular examples, even if the premises were true, the conclusions would not have to be, by that very fact, ipso facto, have to be true. So I'm going to have made some predictions for some of these questions as to what I think you would have said. And what I've also done is to provide some answers from a previous cohort of students. So I've got some graphs that I can show you, showing how a group of about 30 students responded previously, and we can see how well I did in the predictions that I made. So on the first syllogism, my prediction is that you would have answered yes to the Rose syllogism. You would have said it is valid, and you would have answered that question quickly. I predict that many or most of you will have answered no to the Mouse syllogism, and you would have done so quickly. And that many or most of you would have said no to the Wompit syllogism, and you would have done that slowly. So the first 2 you would have answered quickly, and the first one you would have got wrong, the second one you would have got right. The third one you would have got right, I think most of you would have done, but you would have taken a little bit more time. So here's what we got from a live sample of students. This was last year. So the premise is all living things need water and roses need water. Those are the 2 premises. So the question is, therefore, is this syllogism valid? Therefore, roses are living things. Is it the case that roses have to be living things if you accept the first 2 premises as being true? All living things need water. Roses need water, therefore roses are living things. So in the sample of students last year, it was a 50-50 split. So I said that most, it was actually half, so did slightly better across the group than I predicted. Why isn't that syllogism valid? Well, the reason that it's not valid is saying that everything that's living needs water doesn't necessarily mean that everything that needs water is living. So the fact that you happen to know that a rose is a living thing is irrelevant to this statement. It's a question of logic. You can easily see through this, and even when I say that, I know that sometimes people are still looking at it thinking, but I don't get it. Why isn't it the case that if all living things need water and roses need water, why doesn't it logically follow that roses must be living things? You can illustrate this to yourself by replacing the word roses with cars. So if you reread that back to yourself, all living things need water, cars need water, therefore cars are living things. You can see that the structure of that syllogism is not actually valid, because just the statement, what you're saying is all living things need water, yeah? And just because something's living doesn't mean that, and that it needs, sorry, just because a living thing needs water, I confused myself on this as well. Just because all living things need water, it doesn't mean that anything that needs water is a living thing, yeah? So that's why this syllogism is not valid. The first two statements, the premises, do not guarantee the truthfulness of the conclusion. And hopefully that's clear enough. And I think the car example really helps to clarify that. To turn this into a valid syllogism, and I'll see if I can work this out myself because it always trips me up when I try it. If you wanted to make this a valid syllogism related to roses and water, you could say something like, roses are living things. Sorry, no, that would be the opposite, wouldn't it? You could say, all living things need water. Roses are living things, therefore roses need water. That would be a valid form of this type of syllogism. So all living things need water, roses are living things, and therefore roses would need water. So you could flip it around like that and it would become valid. But in this current form, it's not a valid syllogism. Okay? It may seem a little bit pointless, but I'll explain to you why this matters in a moment. Second one, so I said here that the majority of you would get this correct, and so as it's not a valid syllogism, here the answers from the group last year, 94% of people got this one right by saying it's not a valid syllogism. And the syllogism goes, premise 1, all insects need oxygen. Premise 2, mice need oxygen, therefore mice are insects. And it's not a valid syllogism, because again, using the example of the roses and water just now, just because all insects need water, it doesn't mean that that just because all insects need oxygen doesn't mean to say that the only things in the world that need oxygen must be insects. So knowing that all insects need oxygen and then knowing that mice need oxygen doesn't actually mean that mice must be insects. We know that. Now, what's interesting here is that I said that you would answer this quickly. And I suspect most of you did, and certainly in previous classes in a live setting, people do report that they get to the answer of this one quite quickly. And quite clearly, an overwhelming majority of people got it right. We'll come back to the reason for that in just a second. So now we're on to the Houdon class of wompits. All animals of the Houdon class are ferocious. Wompits are ferocious, therefore wompits are animals of the Houdon class. Is this a valid syllogism? So as predicted, the majority, slightly less, so it was 94% last time, 89% this time, the majority of students got this one right. They worked out that just because all animals of the Houdon class are ferocious, they worked out that just because a wompit is ferocious doesn't actually mean that they must be Houdon, because what you're saying is, if the first premise said, anything that is ferocious is a member of the Houdon class, then if a wompit was ferocious, you would know that it would have to be in the Houdon class. But it isn't what it says. It just says that everything in the Houdon class is ferocious. There could well be other ferocious things out there, and it could be that wompits are one of them. Now, what's interesting about this one, of course, is you've got no prior knowledge, I would hope, I think, as to what a wompit or the Houdon class is, because they're made up, they're imaginary. And so you have to spend more time on this, and that's why I made the prediction that you would spend a little bit more time thinking about this than you would have done with the first two. So why is it that these predictions tend to pan out when you run this sort of experiment? And I've been doing this for years, always the same pattern. People get the first one wrong, and the majority, or in this particular example, half of the students last year got it wrong, but then the majority of people get the second two correct. But the speed thing is also interesting. Now, part of the problem is either the believability or the unbelievability of the conclusion interferes with our thinking. The instruction for a syllogism is nothing to do with whether or not the statement is true or false. It's whether it's valid. Do the first two statements guarantee the truthfulness of the conclusion? It's logic, yeah? It's logic, not general knowledge. But if you know something about the conclusion, if you happen to know that mice aren't insects, if you happen to know that roses are living things, either that kind of negative knowledge, knowing something isn't true, or that positive knowledge, so knowing something is true, interferes with the conclusion that you draw. And so in the first example, people rush and kind of go, oh yes, yeah, no, absolutely, roses are living things. I know that, that's a fact, that's a thing that I know. And instead of working out the logical sort of sequence of the syllogism, people just jump to the conclusion, go, yeah, that one's right. And so the majority of people, in most experiments with this particular example, end up getting it wrong, and they get it wrong quickly. But interestingly, with the mouse example, people get the answer right quickly. They tend to go, yeah, no, I know that mice aren't insects, that's ridiculous, that's absurd, and they say no. But interestingly, it's probably not for the right reason. It's probably not because they went and did the logic thing. They just happened, their pre-existing knowledge happened to be consistent with the idea of this being an incorrect or invalid syllogism. But then in the final one, the only thing that you can do is literally do the maths. All you can do is work out, so what does this mean? Does it, are all the ferocious things in the world in the Houdon class? No, that isn't what it says. It says all the Houdon class things are ferocious, but it doesn't say that all the ferocious things are Houdons. So now I know that a Wompit is ferocious. Well, it doesn't mean that it's in the Houdon class. It could be a different type of ferocious thing. Oh, therefore it's not a valid syllogism. So it takes more time. You have to invest the mental effort to answer the question. And the problem that we have as humans is that wherever possible, we tend to avoid putting this mental effort into things, particularly if they're things, as in this case, it's not high stakes, you're not getting a mark. Probably should have made that clear at the start. I'm not giving you marks on the basis of how you respond to this particular test. There's nothing in it for you, really. And if you can take a quick mental shortcut and kind of go, yep, roses, living things, done, get the answer correct, and so on, then you do that. And then when you're faced with a situation where you've got no prior knowledge, well, of course, you have to do the math, you have to put in the effort. So what about the questions on moral dilemmas? So these aren't particularly, sort of pleasant examples, but this is called the trolley dilemma, or the trolley problem. And it's commonly used. If you watch The Good Place on Netflix, you'll have seen this used in a particular episode. It's been referenced many times in many forms. And essentially, this idea of the greater good: is it okay to sacrifice the few to save the many? And if you're in a situation where, in this particular sort of these two examples, you can do something that would save 5 people but kill 1 person, is it morally justifiable? Now, unlike the syllogisms, there is no right or wrong answer to this sort of question. It's a question of moral judgment. What's interesting here is that you're asked the question twice, but in 2 different ways, and that's the comparison that I'm interested in drawing some attention to. What we tend to find is that most people, the majority, not a massive majority, not like 90% or so, the number of times that I've done this over the years, it's maybe slightly more than 50%, 50-60% of people. Sometimes it's about 50-50, but most people tend to answer yes to question 4. They say, yeah, okay, if I pull a lever, the trolley goes off in a different direction, it kills 1 person, but 5 people survive. What people tend to report as well, though, is that question 5 is more difficult. People, particularly those that said yes to question 4 about pulling the lever to kill that leads to the death of 1 person and saves 5, the people that said yes to that one say they feel like they want to say yes to the second one. They're literally having to make physical contact with somebody to push them over a bridge. But they struggle more with the moral justification. It's just a feeling. It just feels wrong. It feels more icky that you're having to make physical contact with someone and it leads to their death, as opposed to just pulling a lever from a distance. Now, practically speaking, there is no difference. If the man on the bridge that you push off was, instead of that, down the track somewhere and you pulled a lever, does it make any difference to him whatsoever if you pushed him over the bridge or pulled a lever? Either way, he ends up dead. And it makes no difference to the 5 people who are saved. Either way, they're saved. The mechanism by which you did it, whether there was a lever between you and the person that dies, or nothing and you physically touch them, the only person it really matters to is you, isn't it? But we nonetheless still feel that quite acutely. In both examples, the action is the same. The outcome from the action is the same. So let's take a look at the responses that we got last time around. So In the first example here, interestingly, we had, contrary to what you often find, only a third of students in the group said that they think it would be okay to switch the tracks and leading to the death of one person, whereas 2/3 of the group felt that it was wrong. So, i.e., it's better to do nothing. It was kind of, and in discussions about this, people often give various different rationalisations and say, it's not my role to sort of play God, as it were, or to intervene. Whereas other people take the moral perspective that actually choosing to do nothing is the same thing as making a positive action. You're nonetheless still making a choice. You could have done something, and then people get into these really sort of hyper. But what if it was to stop? How do I know that it's not going to stop for sure, and so on? But it's a thought experiment. In question 5. What is consistent here is far fewer people said yes in the second example. So you see, I'll just go back again so you can see that. It's a third of people, 33% of people in the first example say yes, it's okay. But then 22% of those people changed their mind. And in the second example, a third or 2/3 of the 1/3 who said yes initially changed their mind and say, actually, no, I don't think it's okay. And what I hope's not true is that some people who said no in the first example decided to say yes in the second example. So I'm assuming that what that shows, because that would be a very odd moral position to take, I won't pull a lever, but if I can get my hands dirty, I'll give them a shove over the bridge. That what's going on here, I think, I hope, is that effectively what we're saying out of this initial group of students, 33 and 67%, that the only 11% of them were going to willingly say yes on both occasions. So there's 11% of the group overall who said yes to the first one and then said yes to the second one. But the majority in both cases said that they felt it would be more morally justifiable to do nothing on either occasion, allow more people to die, allow the other person to survive, but ultimately not have taken any action. And so it's that change between the first two questions that's more interesting. What's interesting about this, so there was some research in 2005 looking at what I described in the context of this sort of trolley problem, this philosophical dilemma that's used to try to explore and understand morality. Green in 2005 asked participants a variety of these different types of what we call less personal and more personal questions. And you can imagine lots of different permutations of it. Sometimes it can be switches and levers, but there's lots of other examples that you could imagine. And this also has relevance, in fact, just as a slight aside, to understanding things like modern warfare. Of course, now we're moving towards drones, and people can be sitting there, and very often, as you may have seen, people using things like Xbox controllers. So soldiers in the army will be using Xbox controllers, partly because those gaming pads are designed for optimal ergonomic efficiency, and they'll literally be dropping bombs, and you can do that and go back home, so you don't even have to go to the country in which you're engaged in war in some cases. So people can be out sort of doing drone strikes and so on, and so there's a real interest in doing this. It's not just a sort of an abstract moral dilemma. It has some real practical implications for understanding how people deal with these sorts of moral issues. If you're a soldier in fighting a war, and you're on the front and you're in another country and you're sort of living in barracks and so on, that's one thing. But what if you are someone who's in the army and you can literally almost go to the office, play this game as it were with drones, drop bombs and kill people, then go home and have tea with your partner and kids? I mean, it's a very different situation, and understanding the impact of that psychologically, how people process that sort of very odd situation, is partly why things like the trolley problem maintain interest for both philosophers as well as psychologists. But just to focus on what was going on here in this study in 2005, so Green was interested in asking people these questions and found, as I described just now, and what we seem to observe with students last year, and you may well have experienced yourself, is that people struggle with these more personal examples. And what was interesting, though, in this particular study, because they were looking at brain function, essentially, so people were having various brain activity measured as they were doing it, what they found is that in our case, the 11% of people who said yes both times, who were consistent in saying, I think you should intervene, whether you have to pull the lever or push the man over the bridge, those who said yes in both cases took longer to answer in the more personal example, but the regions of the brain that were activated in that context were the regions of the brain associated with emotion suppression. So what this is telling us is that when people are being consistent and they're in those more personal dilemmas and saying, well, I've got to sort of physically push someone, I've got to imagine myself doing it, it feels wrong. The way that people are making that decision to say, I'm going to stick with saying yes, I think it's the right thing to do, the way they allow themselves to do that is to suppress the emotion, to try and push the emotion out of the equation, to not think about the fact that it would feel worse doing it than pulling a lever. And that's how they maintain that consistency. And presumably then what happens for people who change their mind, who say, well, I think it would be okay to pull a lever, but it wouldn't be okay to push somebody, what those people are doing is presumably allowing their emotions to guide their behaviour. And just to reinforce this point, as a moral dilemma, there's no right or wrong answer to this. It's not whether or not you should allow your emotions to intervene in decisions. As I said, for the one person that gets killed, it's sort of immaterial really what your reasoning was behind it. But for an individual, whether or not you think you should listen to your emotions or head over heart, listen to your logic and reason and not your emotion, is entirely a personal choice. But it shows something important here about how decisions get made. So the next set of questions were related to probability judgment. So these questions do have right or wrong answers. And in this particular example, it's something we call a covariation detection task. And you're asked here to estimate whether or not a particular treatment is effective. And most people tend to say they think the treatment is effective. They make a prediction that the treatment itself is effective. But it's not. And let's just go back. I'll show you the question here, and this is exactly what we found. 68%, two-thirds of people responded incorrectly to say they felt this was an effective treatment. Just to remind you what the question said. So, NICE are testing a particular intervention. They want to know if it's effective. And the data that we've got is 200 people got the treatment and improved. 75% got the treatment and didn't improve. 50 people weren't given the treatment and improved, and 15 people weren't given the treatment and didn't improve. So the question is it effective? The majority of people say yes. So let's go back and see why that's incorrect. So the reason it's incorrect is this. It's quite simple, really. If you've got a calculator to hand, the proportion of people improving who do get treatment is 200 out of 275. 275 people got the treatment and 200 of them got better. That's 72.7% of people. But then we also know there are two other important facts there, which are the number of people who didn't get treated in the control group, the placebo group potentially. That's the proportion of people improving who don't get treatment, which is 50, those 50 people who didn't get treated but actually got better, out of 65 in total, which is 76.9%. So actually that tells us that although it's a very small sample, you wouldn't be making judgments about treatment effectiveness on samples of this size, but on the face of it from this particular study, having no treatment seems to be a bit better. The people that were left well enough alone were more likely, slightly, about 4% more likely to improve. So why do people get this wrong? Because the maths involved in that isn't particularly complicated. It's just looking at those two conditions, those who got the treatment and those that didn't, and saying what percentage of them got better in each case. Why do people get it wrong? Well, it's mainly, really, because we focus on that big number, the 200. You're told the first thing that you're told, and the biggest number in front of you, is 200. 200 people got better sounds great. All the other numbers are tiny. Pay no attention to them. 200 people got better. It draws your attention. The question's framed as well, importantly, in such a way that you're told that information first as well. So your eye is drawn to it, and you're encouraged to consider that 200 to be more important. But the other problem that we've got, aside from the fact that we tend to, that number itself was just quite impressive. It was the biggest one of all, and so it sort of gives you this confidence that this was an effective treatment. The other problem that people have is that we tend to avoid thinking about or looking for disconfirmatory evidence. Disconfirmatory evidence effectively is anything that would prove you wrong. If you think something or believe something, then confirmatory evidence would be essentially all the things that you might see or experience or learn that prove what you thought was right. And we tend to be really good at looking for that. We look for information that confirms what we thought. But this confirmatory evidence, really important in scientific thinking and in thinking in general, really, if we're honest. This confirmatory evidence is evidence that would prove us wrong. So depending upon what your particular opinion or belief or whatever it may be is about a particular thing in life, it is important to think to yourself, well, what would I need to observe in the world that would demonstrate that I'm wrong? Is there anything going on that, that around me, or for something I could observe that might actually prove my assumption or my hypothesis incorrect? And we just tend not to do that. We tend not to do that as well. And again, just as an aside here about the way that people process information in this regard, in terms of the whole idea of rational thinking, think about how you might deal with a situation where someone that you don't like has done something that upsets you. How far out of your way do you go when you're in a situation like that? Maybe you're not, maybe you like everyone you know, but imagine just for a second that you know somebody who you don't particularly like and they've done something to annoy you, to upset you. How much effort do you put in to stopping and wondering whether or not the reasons for their behaviour may not have been what you think they are? Have you given it a second thought? Do you spend too much time thinking about that? Do you spend much time asking other people? Or do you just go off complaining about this person to your friends and having a bit of a moan? So we don't look for this confirmatory evidence, even more so when the situation's an emotional one, like dealing with somebody who's your mortal enemy. And so we tend not to pay attention to data that disproves our focal hypothesis, the thing that we think is going on. So as a result of this, in this particular case, again, a low stakes hypothetical example, 2/3 of people fail to do the maths and answer the question correctly and go away assuming that this information that's being put in front of them is true, that it worked and it's great. The next question, this was the XYZ virus question. This is another probability question. Now, I can tell you that the most common response to this is 95%. And I don't have a particular slide to show you this, but generally speaking, in a class full of students or other people, if you give this information in the way that it's presented in the study, most people say it's about 95%. Now, the actual answer is actually around 2%. So people tend to vastly overestimate the likelihood of this positive result, meaning the diagnosis is accurate. Quite important if you think about this in the context of coronavirus and testing and things at the moment, isn't it? But why is that the case? How is it that this test that has this false positive rate of 5%, how can that mean that if you get a positive result, that it's only 2% likely that you've got the XYZ virus in this case, as opposed to 95%? That, based on that particular question and the way it's worded, seems to be correct. The problem's base rates. Base rates refer to the idea of, or the concept of how common something is. So in this particular example, we actually know that the base rate or the prevalence of this particular illness is 1 in 1,000 people. So that means out of 1,000 people, regardless of whether they're tested or not, one of them has the illness and 999 of them don't have the illness. Yeah, so that's the base rate. We also know, because there's a false positive rate for this test, that the test will incorrectly tell us that around 50 people out of that 999 have the virus who don't. So if you test 1,000 people with a 5% positive, false positive rate, false positive literally meaning it says you've got it when you haven't, if that happens only 5% of the time, and bear in mind it's that 5% that gets people to 95, if it was 5% wrong, so it must be 95% right. But because of that base rate being 1 in 1,000, that means that the 999 people that get tested who definitely don't have it, 50 of them actually get told they do. So that means you run 1,000 tests, you get the 1 actual positive, you get the 50 false positives. So that's 1 in a 51 chance that you actually have the virus. So you can see again how the maths work out here. It feels counter, even as I explain it, it feels counterintuitive. You get 5% false positive rate, how can it possibly lead to such a sort of an erroneous result? But it's that problem with the base rate, how common something is. And we tend to ignore these base rates. We tend not to pay attention to them. And there are lots of people, sort of increasingly sort of see accounts on Twitter and so on at the moment, that there's a few automated accounts that I follow on Twitter that look out for people who report on scientific evidence about risks of things, and they make a point of identifying the difference between relative and absolute risk. So when we talk about in the press and so on, and we hear in the press that something doubles your chance, it doubles your chance of cancer, it doubles your chance of dying if you eat this particular food or drink this particular drink or do this particular activity, people hear that, they think, oh, double, that's like doubling it, isn't it, 100% more? But the base rate of your original risk is really important. Because saying that something doubles your risk is relative. It's saying that compared to what your existing risk was, your risk is now twice as much. Now, if your existing risk of of getting a particular illness started out at being 25% chance. There's a 25% chance you're going to get this illness, and if you eat this particular food, it will double it. Well, actually, that's massive, isn't it? Because doubling 25% means 50% chance of getting this illness. You should be concerned. You shouldn't eat that particular food. But what if your risk of the illness to begin with was something like 0.03%? Doubling it only takes it up to 0.06%. That's vanishingly small in terms of your actual risk. So understanding this distinction between relative and absolute risk is a good example of what happens when people either don't know because they're misled by poor reporting, or they don't understand these sorts of things even when they're presented with the evidence. And then we hear about the doubling of risk. If you eat certain things, it sort of increases risk of cancer and so on. And in this case, not understanding why it matters that something that's more or less rare means that these tests are more or less accurate is important. Now, go back to this particular example. Let's look at what happens if we change the base rate. What if instead of 1 in 1,000 people, it was 1 in 100 people? If it was 1 in 100 people, then if you had the test done, if we tested 100 people, we would know that one of them definitely has it. Let's say we'd get roughly 5, it'd be 5, 4 point something, but for argument's sake, let's say it's 5. Then out of those, that 5% false positive rate with a base rate of 1 in 100 means that you'll test 100 people, you'll get the 1 actual positive result, you'll get another 5 negative or false positive results, meaning that your chance of actually having the illness, if you have a if you have a positive result, becomes 1 in 6 instead of 1 in 51. So just that difference between something being 1 in 100 versus 1 in 1,000 means that the test accuracy with the same false positive rate changes massively. The difference between a 1 in 6 chance of having an illness or a 1 in 51 chance of having an illness is massive, isn't it? And if you scale that up even more and go the other way and make this 10,000 or 100,000, then you can see that the test false positive rate of 5% makes it worse and worse and worse. Which is why, in fact, tests and false positive rates in particular, when tests are being developed, that really good tests, you have to get down to like a 99.999 and so on percent chance. Otherwise, really, they're not very useful at all because they pick up too much noise. So questions 8 and 9 were more moral dilemmas, more of these lovely moral dilemmas that tell you something about the sort of person that you are. Now, this two questions side by side, giving you 2 examples of program A, program B, program C, and program D. And effectively, you're asked to make these judgments. And it seems to be, on the face of it, the difference between program A and program B and the difference between program C and program D is really just probabilistic. It's whether or not something's definitely going to happen. You guarantee a certain outcome, or is it going to be, are you going to sort of roll the dice and possibly save everyone or possibly save no one, and so on. The problem that we've got, and what tends to happen in these examples, is that most people prefer program A, and then most people prefer program D. The problem that we've got is that A and C and B and D are identical. So if you prefer program A, then it doesn't make sense to prefer program D, because program C is the same as program A, and program B and D are the same. So you should be consistent in your answers. What you should really do is choose program A and then look at the other example and realise that actually these mean the same thing, therefore I should prefer program C as well, or else change your mind about both. So what we tend to find here, and again this isn't particularly interesting, just seeing that people tended slightly more towards a preference for program A. Essentially program A is saying to us that 200 people will be saved, so it's a very definite outcome. It does mean that 400 people will die, of course, but the way this is written is just to say that you'll save 200 people. Program B, on the other hand, is a 1/3 probability that you save everyone, a 2/3 probability that you save no one. In this case, almost 50-50, slightly more in favour of program A. What then happens is this switch around again. There are some people who preferred program A. In this case, it would be about 12%. So we were at 56%, drops down to 42%. So 14% of people changed their mind, decided that program C no longer seemed attractive, but program C is the same. Program A says that if you adopt that, if you take that particular approach, then 200 people will be saved, which obviously means that 400 people will die out of the 600. And so program C all of a sudden becomes less attractive. Why is that the case? Well, it's fairly obvious, isn't it? Because the way that the wording is framed for program A is telling you the positives. It's saying if you do this thing, you're going to save 200 people. How good are you going to feel about that? doesn't bother paying attention to how many people are going to die. Whereas what program C does is push that into your face. Says, you do this, you're going to kill 400 people, you terrible person. Doesn't tell you about the 200 people that you're definitely going to save. So this is a question or a problem. This just the slide here just goes through that in a bit more detail and explains how the percentage chances, a third and 2/3 and so on, are the same. But the key thing there is really that comparison with A and C, because it's the most obvious one in a way. Why do people respond in this way? Well, really it's about framing. It's about the way that we frame information. When we communicate to people, already saw that with the XYZ virus example just now, telling you about the 200 people that got better before telling you about anything else. People are really susceptible to framing. They're susceptible to the way that information is presented to them. And you can be very kind of Machiavellian about this and present things in a really persuasive way. You know, only tell people about the benefits of a particular option so they're more likely to do it. Or indeed tell people all about the problems with something just to try and discourage them for doing it. If you could take yourself onto TripAdvisor, trying to convince yourself whether or not to go on holiday somewhere, really comes down to whether you sort by the positive or negative reviews, doesn't it? Look at all the positive ones first, you'll probably go there. Look at all the negative ones first, you'll probably find reasons not to. So framing effects are really powerful. They have a big impact on the way that people make decisions. And this was actually the reason that Daniel Kahneman, a very famous psychology professor, won a Nobel Prize for economics in 2002. And he won the Nobel Prize for economics, and sadly his long-term collaborator Amos Tversky that equally contributed massively to our understanding of these sorts of biases in decision making, sadly passed away before 2002, and at the time the Nobel Committee didn't award posthumously to people, although they now do. But Daniel Kahneman, and I think it's sort of widely acknowledged, Kahneman and Tversky won the prize together for economics. The reason they won it for economics and not for something else, partly because there isn't the Nobel Prize for psychology, and probably should be, but the reason was that their contribution to understanding framing and decision making had a big impact on the way that we understand economics and decision making and investment decisions and all that kind of thing. But put simply, framing effects mean that our decisions are affected by the way information is presented to us, but this also has a big consequence on our behaviour. In this particular fascinating study, participants were given a payment for taking part in a psychology study in an American university, and they were given at the end of it payment for taking part. Except the payment was described to them as being either a bonus or a rebate on their tuition fees. Now, we all know tuition fees cost a lot in America, and some universities they're even bigger than they are in the UK. And people leave university with a lot of debt to their name, and so this distinction was quite important. What they found was that a week later, the people who were given the bonus money, they spent it all. They went out and treated themselves. They had this money that wasn't their money. It was something that I wasn't expecting to have. Whereas those people who had been given a rebate were less likely to have spent it and more likely to have banked it, because this was their money. It was being given back to them. It was money they didn't want to have to part with in the first place. So whack it back in the savings account. There we go. I've got a little bit less tuition debt. So that sort of framing effect, simply describing the same amount of money as a bonus or a rebate, had an impact on spending behaviour. Even more interestingly and politically, Lakoff, who's written about sort of politics and this was going back to the time of George Bush in his first term in office, identified and highlighted how tax relief was a consistent phrase used by George W. Bush and his administration. Not tax cuts, not tax reductions, but tax relief. And as Lakoff puts it, this is a cunning political strategy, and I'll read the quote from this text. For there to be relief, there must be an affliction, an afflicted party, and a reliever who removes the affliction and is therefore a hero. And if people try to stop the hero, those people are villains for trying to prevent relief. When the word tax is added to relief, the result is a metaphor. Taxation is an affliction, and the person who takes it away is a hero, and anyone who tries to stop him is a bad guy. Now, we get this in political discourse all the time. People talk about spin and spin doctors and so on. That's essentially what this is all about. Is there a way that you can frame a particular issue and use particular phrases, make America great again, levelling up Britain? If you can hook something on to what you want to do and say, this is the thing, this is the enterprise, this is the project, If you get in first and if you frame it in a particular way, then it makes it very difficult for political opponents to argue against you, because what people have got stuck in their mind is very often a massive simplification, but nonetheless it's stuck in their head. And you take tax relief, for example. The tax relief, as you'll know, different political persuasions, people of different parts of the political spectrum believe in bigger and smaller government, and so people that believe in smaller government and self-sufficiency think that you should cut taxes, you shouldn't have as much tax, people should be relieved of the burden of tax, and we should have a very small safety net for people. There shouldn't be massive amounts being spent on social services and care and so on and so forth. Whereas people at the other end of the political spectrum will tend to think that actually we should have a bigger government, a bigger state, and that state should be taking money in tax and redistributing it to make society fairer. And people, these are just different political views. But of course, the reason for needing tax is to pay for things like hospitals and social care and for that sort of thing. But that isn't what comes across. The focus here is on trying to get you, as George Bush successfully did, clearly, as he got into office. What he's really trying to do is just convince people that it's a relief. It's telling you it's a burden. And that's a really cunning political strategy. Now, on the final question, this was the simplest one of all, and it's the one that consistently more people get wrong, I think, than any of the others. We call this a disjunctive reasoning task. And the answer to this question is quite simply yes. The answer is yes. The problem is most people say the answer can't be determined. So what's going on? So look, just to illustrate my point. The question is, Jack is looking at Anne, but Anne is looking at George. Jack is married, but George is not. Is a married person looking at an unmarried person? And most people say, in this case, it was 89% of the students, responded to say that you couldn't work it out. Based on the information you have, you can't possibly know. And the reason they say that when you ask is because you know that Jack is married, you know that George is not, but we don't know what's going on with Anne. And because we don't know what's going on with Anne, well, clearly there's no way we can answer this question, is there? The problem is, of course, there's only two possible versions of the world here, aren't there? We're not talking about a continuum. We're not talking about height, something we don't know precisely and that it would be impossible or unreasonable to try to fathom. Anne is either married or unmarried. In world one, where Anne's married, because Anne's looking at George and George is unmarried, the answer is yes, a married person is looking at an unmarried person. But in world two, the only other possible permutation, if Anne is unmarried, therefore, because Jack is looking at Anne and Jack is married, the answer is still yes. So regardless of whether Anne is married or unmarried, the answer to this question would always be yes. We call this disjunctive reasoning because effectively what it requires in order to answer the question is to kind of almost take that step back to simulate the way that the world could be in different permutations. And in some questions of this kind, it'd be impossible to work it out. Sometimes the number of variables could be exponentially too big to work out the various different answers. It could be that in some circumstances, when you look at world one and you look at world two, that actually the answer ends up different depending upon Anne's marital status in this case. Now, if that was true, then the answer cannot be determined would be true. The problem is, because in either situation, whether Anne is married or unmarried, because the answer is always yes, the answer to this question has to be yes. And so the problem is, and the reason for using that example as well, is it demonstrates once more that we're cognitive misers. We tend to avoid wanting to invest mental energy, to expend mental effort to answer questions if there's no motivation. Now, had I said to you when I gave you those 10 questions to work through, I'll give you £50 for every one that you get correct, I reckon you probably would have got most of them correct. And if for the moral dilemmas, I'd said the really important thing here is for you to be consistent, I'm sure most of you would have been consistent when you answer the question. But in this lower stakes example that we're giving here, it just demonstrates how susceptible we are to these sorts of changes. The other thing, of course, that's interesting is that if you reflect on your experience of answering those questions, and particularly if you're one of those people that, say, with the trolley problem, changes their mind from scenario 1 to scenario 2, or if you're the person who decides that program A is great but program C sounds terrible, chances are you didn't even realise that you were doing it. You probably didn't realise that program A and C were the same thing. What you read was 200 people being saved, 400 people being killed. It probably didn't occur to you, and it doesn't for many people when they do these sorts of questions and think about these sorts of things. So this sheds some real interesting light on the nature of human rationality, which is what I want to come to next. So what is rationality? Now, rationality broadly is about behaving in ways that lead to you achieving your goals. We all kind of intuitively know what being rational is, largely because it's often used as a slur to call somebody irrational. They're behaving in an irrational way, without logic. In cognitive science, we distinguish between two particular important types of rationality, instrumental and epistemic. Now, instrumental rationality is, I think, what most people would think of. If you ask people, pick a person on the street and to tell me what rationality is, people would mostly come up with an example of instrumental rationality. And in relation to behaviour, instrumental rationality is about behaving in ways to maximise your goals. If you have particular goals to achieve certain things in life, it's instrumentally rational to do things that help you achieve them. If you have a goal to do well at university, it would be instrumentally rational to engage in your lectures, to do wider reading, to hit the library when you can, to make sure you submit your work on time. All of those things would be instrumentally rational if your goal was to do well at uni. It wouldn't be instrumentally rational if your goal was to do well at university, to never turn up, not to watch the lectures, not to read any books, not to do any research around the topic, and to not submit any coursework. That wouldn't be rational. It would be instrumentally irrational. So behaving in ways to maximise your goals is the simple definition of instrumental rationality. Now, epistemic rationality, on the other hand, is one that's often overlooked, and it's not something that people would naturally arrive at most of the time. If you said to people, give me some examples of what it means to be rational, because epistemic rationality is far more reflective. And effectively, being epistemically rational means engaging in evaluations of your goals. So if, for example, you wanted to achieve a particular thing in life, it's instrumentally rational to do the things that help you achieve that goal. But what if you never stop to think about that goal? What if the pursuit of that particular goal is, in the long run, not really making you happy? It's instrumentally rational to keep on doing things to help you achieve it, but it's not epistemically rational to continue pursuing that particular goal if actually the act of doing so is making you unhappy, is causing you some harm. And so the important thing about epistemic rationality to also know is it's not absolute. So epistemic rationality is not about absolute truth or kind of rightness in the world or veracity of a goal. Epistemic rationality is about whether or not your own experience is consistent with the goals that you set for yourself. And so a good example that I like to use here is of religion. Now, I'm not a religious person, I'm an atheist, I don't believe in religion, in God, in spirituality, anything of that kind. And scientists are often kind of held up as examples, and sometimes because of some of the louder parts of the scientific community who are very anti-religion. Often science is held up as being kind of anti-religious and missing all these things and so on. But from a perspective of rationality, of epistemic rationality in particular, it's not irrational to believe in something that you can't prove. Science would, people who are being sort of scientific about religion, so how you can't prove the existence of God and so on and so forth, that's not important. That's irrelevant, really, to the question of rationality. The only thing that would be irrational would be if your religious beliefs were causing you deep unhappiness. If you weren't to change them, if you weren't to try to do something about it, if you were to continue believing in God or a higher power or whatever it may be, and that itself was causing you to be unhappy, that would be epistemically irrational. But if you find comfort in your beliefs, if you find that your spiritual beliefs or your religious beliefs cause you comfort, make you feel grounded, help you sort of feel hopeful about the world, whatever it is that being religious can do for people, and it can do all of those things for people at its best, it's entirely rational to continue believing. You don't have to be, to be rational, be atheist. It's not the case. And so I like to make that point. Again, it's a slight aside to the topic of addiction in general, but I like to make that aside because I think it's important to understand what we mean when we talk about rationality. And I think particularly in the context of addictive behaviour, because of the centrality of spiritual and religious beliefs for people in their own recovery, I also think it's important not to make the assumption that cognitive science and some of these more, what may seem to be sort of more ivory tower notions about the way that we think and about reasoning and rationality are not incompatible with those sorts of ideals and beliefs. So therefore, just to summarise, an instrumentally rational person tends to behave in ways that helps them to achieve their goals over time. Not always, sometimes they might do things that don't, but generally speaking, they do things that are consistent with their knowledge and beliefs to help them achieve what they want to achieve. Whereas epistemically rational people, and these are sort of orthogonal dimensions, meaning you can be higher or lower on both, epistemically rational people try to assimilate new knowledge, try to reflect on the experience that they're having in life, and will from time to time change their beliefs and goals about things. An epistemically rational person is highly unlikely to be described as stubborn. That's probably a good way of putting it. A very, very stubborn person is probably unlikely to be epistemically rational, even if they're instrumentally rational. So isn't this just a question about being smart? Aren't we just talking about intelligence here? Isn't it just intelligent to reflect and to take things on board and to pursue your goals in life? Well, not necessarily. Intelligent people are not necessarily rational. And the problem is that measures of intelligence and the construct of intelligence in and of itself tells us very little about human rationality. Part of the issue is that when we test intelligence, we're usually testing people under maximal conditions. If you want to get somebody's IQ, their intelligence quotient, usually you're testing them in a situation where it's optimal. You're giving them time, there's no distraction, and so on and so forth. And you test them on a standardised test and work out what their IQ is. But the other thing is that IQ tests are primarily testing the capacity of your brain to manipulate information, to withhold information, to retain it, to transform it, and so on and so forth. Hence all those kind of pattern type diagrams that you see in various different types of IQ tests. So it's measuring the capacity of your brain, and that is important. But Keith Stanovich, who's written widely on this topic, uses a really, really nice analogy that I think works well to understand the intersection between rationality and intelligence. He says that studying the capacity of the brain as a measure of rationality is akin to understanding the power of a car's engine without considering the skill of the driver. The power of the car's engine is your intelligence. The skill of the driver is your rationality. And he also suggests that these are things that are by and large independent characteristics, and therefore the simple conclusion here is that smart people, where smart means intelligent, smart people can act dumb. Also moving on to George W. Bush, because in a book by Keith Stanovich, his 2009 book, he talks quite widely about the example of George Bush, who very often people would have mocked and still did about the various slips of the tongue when he was on the public stage, and sort of portrayed him as this kind of bumbling fool. But actually he has an estimated IQ of 120, which isn't genius level, but it's well higher than the average. It's well, he's highly intelligent as far as any measure of IQ would be concerned. But what was also interesting is that he was described by his supporters, people that knew him and worked with him, so not people that had an axe to grind, people that were criticising him. People who knew him and worked with him said he was also very resistant to considering counterfactual or disconfirmatory evidence, and he was always quick to squash discussions of problems with his administration's plans. So if people wanted to draw to his attention a limitation of something that he wanted to achieve, he was really, really good at closing down that debate, using his quick mind, his sharp, fast mind, which is what you would see as a sign of high intelligence, a brain that can think quickly, can hear what people say, quickly tell them what's wrong with it and move them on and stop the discussion. But the problem is, of course, that if what you're doing is using your intelligence to stop yourself having to hear things that might disconfirm what you already think, then that's a form of irrationality, and particularly a form of problem in epistemic rationality, or a failure, lack of epistemic rationality. So what does this mean in the context of addiction? We know that people don't always behave in completely rational ways. We've established this. We've seen that in terms of the way that you responded to those questions, chances are, and if not yourself, then certainly the students from last year whose data I showed you as we've been through this session, we know that people don't behave in completely rational ways. There are lots of different things that can trip us up, framing effects and so on. And it's partly because we're cognitive misers. We tend to avoid expending mental energy wherever possible. But what does that mean for our understanding of addiction? In 1971, Harry Frankfurt wrote a very interesting paper, and it was a paper that was more broadly about understanding desires and motivations and so on. But in this, he identified what I have always found to be a really interesting distinction between what he called different types of addict. Now, Frankfurt's a philosopher, he's not an addiction specialist, but I've always found this very useful. He described the wanton, the unwilling, and the willing addict. The wanton addict he describes as someone who simply engages in their addictive behaviour without questioning their actions, without ever stopping and thinking, is this even what I want to do? Is it making me happy? It's just somebody acting in literally a wanton way. But then there's the unwilling addict, who Frankfurt described as someone who's thought about their addictive behaviour, would rather not be addicted, but find themselves unable to stop. And then you have the willing addicts, the people who have thought about what they're doing, acknowledge that it's an addictive behaviour, but are happy with it and have no intention or desire to stop. And I've always found this interesting, not that this is a clinical categorisation or it's even evidence-based, and certainly it's always been interesting presenting these categories to different groups of students over the years, and particularly for people who have had personal experience with addiction, to hear them talk about how actually these aren't so much distinct types of addict, they're rather phases that you can go through during a kind of a history of addiction, that there are times when you can be very wanton, that you don't think about it, you just do it, you act, you don't think. Whereas the unwilling addict, people have experienced that, times where they felt they wanted to stop but they couldn't and find themselves unable. And then the willing addicts, who are people who have reflected on their behaviour and actually, for whatever reason at that point in their life, have decided they don't want to do anything about it. And there are interesting overlaps here if you think about that in the context of instrumental and epistemic, in particular, rationality, particularly for the willing addict, for someone who has thought about what they're doing and decided that actually there could be other things going on in their life, other things that make them unhappy. They could be self-medicating with alcohol, and they've decided that even though, maybe in a perfect world it would be better not to be alcohol dependent, maybe for that person at that point in their life it feels like the best thing to do. And so I think what Frankfurt offered here in terms of this particular angle on sort of a perspective from in terms of rationality is this idea that we can't always assume that a person who has a problem with addiction is necessarily in a situation where they want saving. There can be points in your life, situations that you can be in, where actually it may feel better to carry on doing it. Certainly for people who are in situations where they've experienced significant trauma, people who may be living very difficult lives, have no stable home to be living in, and people that are sleeping on the street or sleeping rough. Sometimes actually the use of drugs can be a way of just blocking out the pain. And why is that not rational? In the short term, in the long term, we understand that it's very damaging and harmful. But in the short term, if there isn't any other support available, it's not necessarily irrational to sometimes engage in these behaviours. Now, I want to come on to a particular theory that constructs addiction as a rational behaviour. And this is has been a very influential theory over the years, but it's one that has got lots and lots of critics. And it's got lots and lots of critics because despite the fact of describing this as a theory of rational addiction, it's actually not particularly consistent with all of the evidence that I've just described and all of the theory that I've just described with regards to what rational behaviour actually is. But I'll talk you through it. Now, there's a paper by Becker and Murphy who developed this theory, which is a really tough read. Becker and Murphy were economists, and I believe Murphy may have passed away, or Becker, one of the two passed away, and one of them still works in economics. So they are and were economists who were looking to apply principles of economics to understand addictive behaviour specifically. Here's a quote here from the paper. As I say, it's quite a dense paper. This is probably one of the most illustrative examples in the paper that really helps to try to understand it. So I'll read this through and explain as we go what they're talking about. We develop a theory of rational addiction in which rationality means a consistent plan to maximise utility over time. Utility is an economics type word. Utility essentially means positive benefit of some kind, positive reinforcement, you could say. So essentially they're saying theory of rational addiction in which rationality means a consistent plan to maximise positive benefits over time. That's the definition, that's the functional definition of instrumental rationality, isn't it? Having a plan to do things over time that improve, that help you achieve your goal. Strong addiction to the good requires a big effect of past consumption of the good on current consumption. So what they're saying here is that in order to develop an addiction to something, doing that behaviour or taking that substance has to have your past consumption has to have an impact on your future decisions or current decisions. Therefore, really what we're talking about there are basic principles of operant conditioning, aren't we? If you've done something in the past and it's given you a positive reinforcement or a negative reinforcement, that's going to have an increased impact on the likelihood of you doing it again in future. So the idea is that they're essentially, it's quite a descriptive, although they put it in this way, a big effect of past consumption of the good on current consumption. Really, they're just describing here well-established principles of operant conditioning through reinforcement. Such powerful complementarities, and by complementarities here is what I mean by the paper being a little bit dense in terms of the jargon, such powerful complementarities, which literally just mean connections between past and current and future behaviour, cause some steady states to become unstable, i.e. if you use a drug like heroin, it has this very powerful euphoric effect if you get past the initial nausea and vomiting that it will cause after the first few times of using it. The huge euphoria that it causes can make you become unstable in the sense of the sorts of things that you're going to pursue. All of a sudden you've experienced this really, really powerful euphoric positive effect of using heroin. It's going to make you more likely to want to use it again. They are an important part of our analysis because even small deviations from the consumption at an unstable steady state can lead to large cumulative rises in addictive consumption or rapid falls in consumption to abstention. Essentially what they're saying is, you might think of this as a butterfly effect, that one really powerful experience of using a drug like heroin and a really positive experience of using it, it only needs to happen once, and if it creates that instability and you keep on using it because your behaviour starts to change, it doesn't take long, and particularly if the effect is powerful. And it's why you could argue, at least in a descriptive sense, it's not an explanatory theory so far, I don't think. In a descriptive sense, it's true that people can become dependent on heroin far more quickly than, say, they can on a drug like alcohol, which has a powerful effect, but nowhere near, subjectively speaking, an effect as powerful as a drug like heroin. They also say our theory also implies that cold turkey is used to end strong addiction, that addicts often go on binges, that addicts respond more to permanent than to temporary changes in prices of addictive goods, and that anxiety and tensions can precipitate an addiction. Now, one of the difficulties with this theory really is that what they're saying here is just descriptive of what, even in 1988, was very well understood about addictive behaviours. This is something that you only need to speak to people that have been working in the field, speak to people that have had problems with addiction to know that much of these things are pretty well understood. And it's not entirely clear how Becker and Murphy's theory of rational addiction provides an explanatory framework for why these things happen. It certainly doesn't explain it, as far as I'm concerned, in a stronger way than the basic principles of operant and classical conditioning do. So, key assumptions in the theory is that the first here, that rational consumers maximise utility from stable preferences as they try to anticipate the future consequences of their choices. That should immediately make you question the accuracy of this theory. Is it true that rational consumers, and the problem was partly it was the economic lens through which this theory was developed, where in economics there was this assumption, and this was partly why then Daniel Kahneman won the Nobel Prize for economics. There was an assumption in economics that all behaviour is rational, that because there is always a reason for it, that somehow it was always optimally rational. And what Kahneman and Tversky's work shows is really that we're not. We are very, very fallible. We are often irrational. We often don't pay attention to all of the evidence in front of us. We're cognitive misers. So therefore, this idea that somehow a person who has problems of addictive behaviour is a rational consumer who maximises their utility as you try to anticipate the future consequences of your choices really doesn't fit with the evidence that we have about how human behaviour in general works, let alone specifically for people who have problems with addiction. This idea that it's very purposeful and intentional, that when you're using drugs or alcohol, you're doing it for a particular pre-existing purpose for a known reason, that it's going to have this positive benefit. Addictions, even strong ones, they say, are usually rational in the sense that of involving forward-looking maximisation with stable preferences. Well, actually, from the literature on impulse and self-control, we know that when people have problems of addiction, especially drugs like psychostimulants, future time perspective can actually be quite problematic. People can find it hard to think ahead. We know from research, which we'll come to in a subsequent session, we know that research around principles like delay discounting, people can often favour immediate strong rewards over even bigger, more positive rewards in the future. So there can be this kind of immediacy, this impulsivity. So this idea of describing it as being rational seems to play fast and loose with the concept of what we mean by being rational in the first place. A good in this context, a good, again, sort of a term used more widely in economics, is addictive to the extent that use of the good increases the likelihood of future use. That's operant conditioning, that's not an original theory. Individuals who pay less attention to negative future consequences are more susceptible to addiction. Well, that can be true, but it can also not be true. And again, there's not much evidence supplied to support that point. There are problems with the theory. It may seem that I'm not a fan. I'm not a particular fan. There are problems with the theory. One of them is it's very hard to understand. If hopefully I've explained it in a way that makes sense. But if you read the paper, if you read the literature, it's actually a very, very difficult, dense paper to get through. And that's, although that doesn't mean that it's wrong, it doesn't mean that it's an inaccurate theory. It doesn't disprove a theory. It is important working in a field like addiction that what we discuss and what we describe and how we communicate should have some clinical value. If we can't describe things in a way that makes sense to people that are not economists or not behavioural scientists or not psychologists, but nonetheless have an interest, I do think that's a weakness of different theoretical perspectives. It's also difficult to test fairly. Where the evidence shows the model is wrong, there are additional vague factors that can rescue the model. There are certain, there are lots of different sort of caveats and so on. It's hard to know what the theory predicts won't happen. What would be the disconfirmatory evidence that would show it's wrong. But there are big theoretical problems here. It's based on an economic theory of rational behaviour that, put simply, is contrary to the vast amount of evidence we have, from Kahneman to Tversky upwards, all the evidence we have about the sorts of biases that exist in decision making and so on and so forth. All of these things are really problematic for the theory. Kahneman and Tversky's work I've already mentioned. An economist at the time had assumed that all behaviour was by definition rational. So actually describing in this context addiction as being rational is nonsensical in a way, because you're just saying the fact that people did it means that it must be rational. But if by rational really all you're saying is there is a reason for it, well, that's unhelpful. That's not making a contribution, because the question becomes, what is the reason? And the evidence and examples we discussed previously demonstrate that this is hard to justify, the idea that all behaviour is rational. We know that it's not. It's rational by a degree. We can be instrumentally or epistemically rational or irrational at the same time. There's a paper written by Regan that argues as well that the theory of rational addiction is logically inconsistent. It fails to explain, for example, the different reasons for recovery and relapse. You can draw attention here to Frankfurt's distinction between willing and unwilling addicts. How does the theory of rational addiction help us to understand the difference between the two? The idea of being a willing addict, somebody is maybe consistent, but an unwilling addict, a person who's decided they don't want to do it, that doesn't have a plan to consistently maximise utility over time, they don't want to engage in it but find that they still do. How does the theory of rational addiction help to make that distinction? It essentially treats somebody who is an ongoing user in the same way. The fact that you continue to do it means that you are maximising utility, regardless of whether you are willing or unwilling, in fact. And there's this further critique, and I put this in here because you don't often come across published peer-reviewed reviews of things that are quite as scathing as this particular review, and it's one of my favourites in the academic literature. Rogeberg is an economist working in economics, who wrote a paper in 2004 about the theory of rational addiction and had this to say. The theory of rational addiction is empirically unfalsifiable, based on wildly inaccurate assumptions and poorly interpreted in a selective way that makes it seem plausible to some economists. That's a mic drop moment. Somebody get the burn cream. That's about as difficult as it gets as an academic in terms of criticising one another. But I think that really summarises, and the Rogeberg paper is well worth a read. And actually you learn more about the theory of rational addiction, from my perspective at least, by reading the paper by Rogeberg and Regan than you do from reading the original. But I would recommend reading the original. The theory of rational addiction has had a big impact in many ways. One of the reasons it has, well, of course, it makes comments at the end, going back to that earlier slide, that change in price has an impact. So part of the reason it's gained this sort of attention is that it has had, from a policy perspective, things to say and to recommend. So, what have we learned? We've covered quite a lot of content. We've learned that we're not rational. We've learned that we are easily influenced by someone like me, sort of a poor man's Derren Brown, conducting these psychological tricks and making you behave in logically inconsistent ways, in some cheap parlour tricks using syllogisms and so on and so forth. So we've learned that we're not rational. We've learned that there are lots of ways in which our cognitive apparatus can be undermined. We can be led to think things in certain ways. We can be, in the context of looking at two simple examples of a decision that you need to make, we can be shown the same option, but if it's shown in two slightly different ways, we can, within seconds of deciding that we prefer one thing, decide that we no longer prefer it. Program A, yes, I'll go for that. Show me program C, which is the same thing but present it slightly differently, and I'll tell you I'm not interested anymore. So we're really susceptible to those sorts of influences. We've also then considered the relevance of that in the context of addictive behaviour and understanding fundamentally what human rationality is all about. This distinction between instrumental and epistemic rationality, the driven goal-oriented form of rationality that is instrumental, and the epistemic reflective capacity that people may or may not have to differing degrees, and how they can also have a big impact on the decisions that people make over time. And we've reflected what that might mean in the context of understanding addictive behaviour, where there's so much about addictive behaviour and addiction itself is often construed as being this loss of control, where people may or may not be willing to engage in the behaviour, and understanding human rationality in those processes provides us with some mechanism for potentially understanding that. And then finally, we went to look towards the theory of rational addiction, which is the first of the choice theories proper that we'll be looking at, that offers an analysis based upon a particular interpretation of what rational behaviour really means, to understand what that has to say in the context of understanding addictive behaviours. And we've seen that that has had an impact. It's had an impact in terms of policy changes around pricing and so on, that if you can change prices, it can change behaviour, and there's some truth to that. But for people that are most heavily addicted, often it has a diminishing return, that you keep putting the price up and a very small proportion of the population will continue to smoke, for example. So there are limitations to the theory of rational addiction, but it's an important theory and one worth trying to get your head around in order to understand some of the different perspectives, that rather than looking at addiction as a learned phenomenon, looking at it as a problem with impulsivity or with neurological problems, that understands addiction as being a problem involving difficulties with decision making, difficulties that can be brought about by lots of different external factors. So I hope that's been useful.